Hello Gators, this is 7-1 dilations. I can dilate figures and identify characteristics of dilations. Dilations are enlargements, that's when a shape will get bigger, or reduction, and that's when a shape starts big and gets smaller. Dilations can be seen in a variety of situations like photography, arts and crafts, Russian nesting dolls, graphing calculator where we can enlarge or reduce the window. We'll also see it in food service, the small, medium, large, extra large, and in different products as well, like pizza boxes, this bigger version, the smaller version, and in toys. Let's take a look at dilations in the coordinate plane, especially where the center of dilation is at the origin. So here is the origin right here, and triangle ABC is the pre-image. So this is the pre-image. Now what we're going to do is we're going to multiply every x and y by the same number. In this case, we're going to multiply it by a scale factor of 2. So this x coordinate will be multiplied by 2, which will be 0. This y coordinate is multiplied by 2, which will be 4. We'll do that for each one of these points and then plot them. And notice that we have A prime, B prime, and C prime, and this is going to be called the image. This is the after, and you can see that it grew bigger. And so dilations involve multiplications. This particular process that we did was we took all our x's and y's and we times them by 2, 2x, 2y's. And this is where our dilation is, the center is at the origin. Let's go ahead and do a problem. Here is a triangle, and I would like to do a dilation of 4 with center at origin. So the rule is going to look like this. X comma y maps to, and the number 4 is what we're multiplying by, so it's going to get very large. 4x, 4y. So this is our pre-image. Our image will be multiply both x and y by 4. So this is going to be 4, 0. And this will v prime will be 0, comma 4. And j prime will be negative 4, negative 4. Let's go ahead and graph that. Let me change colors. So a prime will be 1, 2, 3, 4. This is a prime. And v prime will be 0, 4, 1, 2, 3, 4, v prime. So it's going farther away since we're multiplying by 4. And so from the origin, this j is going to go negative 4, 1, 2, 3, 4, 1, 2, 3, 4. So this is j prime. So what v is doing is going farther away from the origin, a is going farther away, a prime is farther away, j goes farther away, and then we can go ahead and draw the new triangle, and we can see that the new triangle will be 4 times bigger. But also notice that the angles did not grow. The angles stayed the same, just the sides grew. Let's take a look at a dilation scale factor of 1/2. So our original right here, this is the pre-image, and the pre-image looks like a parallelogram. And we are going to, our rule, again, center of dilation at the origin, we're going to multiply it by 1/2. So each one of these x and y coordinates will be multiplied by 1/2. This will be our image. And after we graph it, we can see that it is smaller. And it's going to, these sides will be 1/2 as big as the original. The original was 1, 2, 3, 4, 5, 6. Now this is 1, 2, 3. Notice again the angles did not change. This angle measure looks like it still stays the same. So it's the sides that are changing, but the angles are not. Let's go ahead and do a problem. This time it's a scale factor of 1/3. So the rule will look like this. X comma y maps to, and it'll be 1/3 x, 1/3 y. And again, what we're trying to do is we're trying to bring the points in closer to the origin. So it's only going to be 1/3 of the way instead of as far as it was. So this point will be 1, 3, and n prime will be 2, 0, and then this will be 1, negative 2, and this will be negative 1, 0. Let's go ahead and graph it. M prime will be 1, 1, 2, 3. So here's M prime. So M prime is here, and it's getting closer to the origin. 2, 0 right here. That is going to be N prime. N was over here, and it's being brought closer to the origin. And negative 1, negative 2 right here. So here's O. O wants to get closer to the origin. And then we have P prime, which is negative 1, 0 right here. P prime, let's go ahead and graph it so we can see what it looks like. And you can see that it's still a quadrilateral. All the angles will remain the same. And it's going to be 1/3 the length. This will be 1/3 of this length. This will be 1/3 of this length, and so on. So let's take a look at a picture and see if we can't figure out the scale factor of the dilation. Now we know this definitely is an enlargement. How do I know? Well, first I look at comparing the pre-image with the image. Now I know that P is a pre-image way we describe it, and P prime is the image. And the image looks bigger, so that's why I'm saying it's an enlargement. Now, to get a scale factor, what we do is we compare the distances from the center of dilation. Here's the center of dilation, C. So the new distance from here all the way to the image is 12. And the distance from the center of dilation to the original image is 8. And so we say it has a scale factor of 3/2. 3/2 is bigger than 1, so that's why we can say it's an enlargement. Let's go ahead and take a look at this. I can see this is the pre-image because it has just P. And I can see this is the image, and it looks like it wants to be closer to C. Notice that the paperclip is smaller, so this is a reduction. And let's compare the scale factor. Scale factor is going to be new over old. And here's the new distance from the center of dilation. It's 18. And the old distance was 30. Let's go ahead and reduce. 6 goes into there 3 times, and 6 goes into there 5 times. So this is the scale factor of 3/5. 3/5 is a number between 0 and 1, so that's why it is a reduction. Let's find the scale factor of these. So this is a triangle and another triangle. I can see this is the pre-image because it has just the P, and I can see this is the image. Okay, and I'm going to do the new distance. The new distance is 6, and the old distance is 14. And if you reduce that, 2 goes into there 3 times 3/7. 3/7 is a number between 0 and 1. This is definitely a reduction. So anytime the scale factors between 0 and 1, we know that the figure is getting smaller. I can visually see this is an enlargement, so I'm going to expect that my scale factor is bigger than 1. So the scale factor is new over old, and the new distance is 24. The old distance is 9. And 3 goes into here 8 times, 3 goes into here 3 times. This number is bigger than 1, and so that validates the idea that I saw an enlargement when it's bigger than 1. Let's take a look and see if we can't find a rule that describes the dilation. And we again are doing dilations with center at the origin. So notice that as you go out, A wants to go farther and farther out, so this definitely is an enlargement. And so therefore I expect that a number that I'm multiplying will be bigger than 1. So I have x comma y maps to, and now here I have listed all the things, and it looks like 2 becomes 4. How can 2 become before? Times it by 2. 1 becomes 2, times it by 2. So it looks like I'm multiplying both x and y by 2. So this is the rule I am using to go from triangle ABC to triangle A prime, B prime, C prime. All right, let's take a look at this. We see that the original, this is the pre-image because it doesn't have any primes in it. and I can see that the prime here is the image. Now this definitely is a reduction. So I'm probably multiplying by a number between 0 and 1. So this will be x comma y maps to, and I'm going to compare how x changes. And it looks like I'm multiplying by a third. Take 6, what do I multiply it to get 2? It looks like 1/3. And that looks like what's happening with all the other numbers. So I'm taking 1/3 of x and 1/3 of y. That is going to be my rule, and I expect that because a number between 0 and 1 will make the number a reduction. I mean the figure a reduction. And here's the summary. We are now working with dilations. We have the idea of multiplying x and y by the same number, and the idea that dilations preserve angle measures. So even though this has become enlarged, the angles have not become enlarged. The angles are still the same. Only the sides have changed.